Okay, good morning. Today we're going to go to our final example on combined loading, and I'm going to deal with a circular structure today. Okay, and then after this example, I'm going to go to a new topic, which is 2D and 3D Mohr circle. Okay, so 2D Mohr circle, you guys have seen it before, but I will revise again for 2D, and then we're going to do 3D Mohr circle. Okay, so I'll put down here not in test 2. Okay, I will not test this in test 2. I don't want you guys to get confused. So where we finish off on Wednesday is we break down the resultant force of 13 kilonewton. And this 13 kilonewton is acting on the YZ plane. Okay, so if you look at YZ plane, that's where the 13 kilonewton. So you have a dy coming down at 12 kilonewton, and you have a dz coming down at 5 kilonewton. You can use sine, cosine, okay, or you can use similar triangles. The answer will be the same. So I use similar triangles. So as usual, the protocol that we're going to use is we are going to draw this structure at different view. Okay, like how I always teach you guys to solve this. So we are going to look into the we're going to look at it along, we're going to look on XY plane. Okay, so from here, we'll draw our structure, just a sketch. Okay, so it looks like this. Okay, so this is how our structure will look like. And then we have, we draw in our centroid that's relative to our element. So now this is where, so this is built in. So over here, this is our element H. Immediately draw your centroid. So what you have here, you have a dy that is coming down. Sorry. You have a dy it's coming down. So dy is 12 times 10 to the power 3. And you have a cross. Okay. And that will be your 5 times 10 to the power 3 Newton. Okay. So now what we are going to do, so we have, this is our rotation in our Z. Right. So from here, we know that we are going to have a moment in the Z. So the moment in the Z, okay, we're not going to consider the 5 kilonewton because do not analyze the dot and cross. We are going to analyze the 12 kilonewton. The 12 kilonewton over here is going to induce two things. Okay, it's going to induce a moment about Z. So moment about Z is equal to 12 times 10 to the power 3. And we are made aware that the distance from here to the edge it is 0.15. Okay. So you take it to the centroid, not take it to the element, because the applied force is parallel to the what? To the centroid, right? So this is multiplied by 0.15. So once you do this, so 12 power 3 times by 0.15, you get 1,800 Newton meter. Let me do it again. 12 power 3 times 1,500. So it's going to induce a rotation this way. Okay. So we're going to rotate this way. So this is our MZ, right? So from here, we know that on element H, MZ is going to see, we're going to see compression because the head of the moment vector is compression, the tail end is tensile. Okay. Now this 12 times 10 to the power 3 Newton is not just going to induce a moment. Okay. It's also going to induce an axial load, right? So we know that it's going to induce an axial load down here, okay, of 12 times 10 to the power 3. Okay, so from here, we write down that we are going to have Py is equal to 12 times 10 to the power 3 Newton. And we also know that element H, right, due to the 12, is also going to be what? In compression. So from here, anything else to do? Nothing else, move on, okay? So we're going to view from a different view now. We're going to view from the YZ plane. Okay, so we are going to view from the YZ plane now. Okay, so if I'm going to draw this on a YZ plane, it will look like this. Okay, so you have the structure now, and then you have the round shaft. Just a sketch, okay? I know this is a horrible sketch. Don't remind me, okay? So now we again draw in our element H, right? And then we put in where our centroid is. Right, so there's our centroid. So we know that we have a load coming down at 12 times, coming down from here, is coming down at 12 times 10 to the power 3. And this is going towards the right and is going at 5 times 10 to the power 3. So we are looking at the front view now. Okay, so our eyes are now over here now. Okay, so we are looking at the front view now. So over here we can see that if I'm going to have we know that this is our rotation in our X, right? We know that we are going to have a moment, right? At the x-axis, I'm going to assume positive is going in a clockwise direction, right? So this will be equal to 5 times 10 to the power 3. The fact that the applied force is perpendicular to the what? To the centroid. So therefore, the distance to be taken is this distance over here. It's up to the element, okay, down to the element. Okay, so sorry, wrong color. So down to the element because it's perpendicular to the centroid. Okay. And that distance over there is 0.3 meters. No, 0.2 because you have 300 to the bottom. You have an offset of 100 to the element. So this is 0.2. So this will be multiplied by 0.2. Okay. 5 power 3. So it will be 1,000 or 1 times 10 to the power 3 Newton meter. Okay. So now we realize that on element H, right, is at the centroid. So you can write over here element H is equal to 0 stress, right? Because it's exactly at the centroid. Now, in your exam or the term test, when you see this, you have to resolve all the forces. I know the stresses will be equal to 0, but you have to tell me that. Okay, no need to analyze the 5 times 10 to the power 3. It's not going to induce any stress. No, you have to write down and tell me that. Okay. So from here, we are also going to have a V shear stress in the Z direction, which is due to 5 times 10 to the power 3 Newton. Okay. Then we are going to take another view. Okay, we're going to take another view. So the view that we are going to look at now is the XZ plane. Okay, we're going to view the XZ plane. So on the XZ plane, what we see is this. Okay. And this is our hidden detail, the shaft below. And over here, we have our centroid. The green is always our centroid, okay? And then from here, we know that we have a view. We have a force over here, 5 times 10 to the power 3. We have a crossover here, 13 times 10 to the power 3, which we could ignore, okay? So now, over here, this is our rotation in the Y, right? So the 5/3 times 10 to the power 3 Newton is going to induce a deformation. So the deformation will look like this, okay? So when it deform, different color, come on. It will deform this way. Okay? So this is our deformation pattern. However, if you look at the centroid, okay, we view the centroid. So this is our centroid. Did not deform. Right? It did not move at all. Yes. Is it, I got it wrong? Should it be 12 or I got it? Oh, it should be 12. Thank you. Yeah, it's 12. The red. Thank you. I owe you so much beer. Okay. So what you see over here, right? The centroid did not deform. Unlike the first two cases, right? When we apply the force or the moment, the centroid will deform this way. Right? This one will deform this way. This one will also deform this way. Right? So for this case, the dot remain there. So when that's the case, it's going to be the torque. Okay, so it's going to be the torque about the y-axis. This is equal to 5 times 10 to the power 3. And the distance is equal to what? Let me see what's the distance. The distance is equal to 0.15. Why? Because the distance from here to here is 0.15. Okay. So from here, we have 5 power 3 times 5.15 is equal to 750 Newton meter. Okay. So 5 power 3 times 0.15, 750 Newton meter. Okay. So we're going to calculate our normal stresses now. Okay. So let's bring up the formula that we're going to apply. So we know that we're going to, based on the axis, let me copy and paste over here rather than moving up and down. You get headache, I get confused. Let's have this image over here. So what you see now, we are going to calculate the stress on the y direction at element H. So this will be equal to one element H. So this is going to be Py. So we know that there's a minus Py over A, right? Then we have Mx over Ixx multiplied by Y. So you look at the moment about X is going to be equal to 0. Okay, so this one, if I put plus, we know that this whole thing will be equal to 0 because we realize that Y, because it's at the centroid, right, is equal to 0. Then we have our Mz over Izz multiplied by, is it Mz? Yeah. Oh, so sorry, this is Z and this is X. Okay. So if you look at Mz is going to induce a compression. We have analyzed it. So this is going to be